Lesson 29 is about rounding whole numbers, rounding mixed numbers, and estimating our answers. So if I were to say that we went to a football game and there were about 4,000 fans at the game, that is a rounded number. The newspaper might report that there were 3,947 fans at the game. That would be an exact number. Round numbers are often used instead of exact numbers, usually because it's easier to take that answer, that rounded number, and do some calculations with it, or it's easier to understand, or maybe even because an exact answer isn't needed. One way to round numbers is to consider where the number is located on the number line. So here we have 428. Round 428 to the nearest hundred. Here's a number line of the hundreds mark. If I estimate where 428 is, I know that it would be about here. What hundred marker is it closest to? We can see that it's closest to 400. So rounding 428 to the nearest hundred would be 400. What about rounding 428 to the nearest 10? Here I have from 400 to 500 with markers at every 10. 428 would be about here. When I look at where that would be closest to, what nearest 10, I see that it would be closest to 430. So rounding it to the nearest 10 is 430. How can I do that without a number line? If I'm asked to round 428 to the nearest hundred, I'm going to underline the hundred and then circle the number after that. So the tens place. Is a 2 going to be closer to 0 or closer to 10? 2 is going to be closer to 0. So I would make it 40, and then anything after where I have estimated will also be a 0 to just hold the place. So it would round to 400. If I'm asked to round 428 to the nearest 10, I might underline the 10 spot, and then I'm going to circle the next one. Is the 8 closer to 0 or closer to 10? It's closer to 10, so it's going to round this 10 up. Imagine it saying 420 plus 10 more, because the 8 is closer to 10 than it is to 0. So 420 is going to go to 430. If our circle digit is 5 or more, then we add 1 to the underlined digit. Because 8 was higher than 5, we added 1 to the 2 and made it 430. If the circle digit is less than 5, then we leave the underlined digit just the same. We replace the circle digit and all the digits after that with zeros. This rounding strategy is sometimes called the 4-5 split. If the circle digit is 4 or less, we round down, and if it's 5 or more, we round up. Let's practice some more. We're going to round 4,391 so that there is only one non-zero digit. That means we are going to be rounding to this place. I only want one digit that isn't zeros. I'm going to circle this number because that's where we're I'm going to underline. I'm going to underline the number that we're rounding to, and I'm going to circle the next one. The 3 is not bigger than 5, so it does not add 1 to the number that's underlined. So we're going to keep the 4 the same, and then the circled number and all the rest of them become zeros. So one non-zero digit is the 4, and the rest are zeros. So 4,391 rounds to 4,000. We're going to round 92,487,000 to the nearest million. So I'm going to underline the millions place because that's where I'm rounding. I'm going to then circle the next one. I look at that 4 and I say it is not 5 or bigger, so it does not add 1 here. So I'm going to keep the 9 and the 2, and then the circled number and everything after it becomes zeros. So 92,487,000 rounds to 92 million. What about when we have to round mixed numbers? What is a mixed number again? A mixed number is a whole number and a fraction. So 13 and 8/12 is a mixed number. I have my whole number of 13 and then 8/12 is a fraction. If I'm told to round to the nearest whole number, how am I going to do that? I'm going to underline my 3 really on my 13, and then I'm going to be circling my fraction. Does this fraction make the 13 go up 1 or does it make it stay at 13? Is this fraction 1/2 or bigger, or is it not? We're going to look at this fraction. We have to decide what it's closer to. Is it 1/2 or bigger, or is it not? So we could look at the 12 and say, well, half of 12 is 6. So 6/12 would be equal to 1/2. Is 8/12 bigger than 6/12 or less than? Well, it's bigger than 6/12. So it is more than a 1/2. So that would make this 13 go up to 14. So rounding to the nearest whole number is going to make it 14. Let's do one more example. What about rounding 5 and 5/7 to the nearest whole number? I know that I'm going to be looking at this fraction. Is it bigger than 1/2? What is half of 7? Well, that's a little bit difficult because it doesn't cut in half evenly, but it's between 3 and 4. So between 3 and 4 over 7 would be halfway. So actually it would be 3.5 over 7, though we don't typically use decimals in fractions. But if I know that 5 is bigger than 3.5, then I know that 5/7 is going to be bigger than a half. If it's greater, then it's going to make this round up. So my answer is going to be 6. Rounding can help us estimate the answers to arithmetic problems. Estimating is a quick and easy way to get close to an exact answer. Sometimes a close answer is good enough, but even when an exact answer is necessary, estimating helps us determine whether our exact answer is reasonable. One way to estimate is to round the numbers before calculating. Especially when we're working with fractions and you're still a little unsure about what that number should be. 5 and 7/10, well, that's close to 6. 3 and 1/3, well, 1/3 is less than half, so I'm going to round that to 3. 6 times 3 is 18. So before I work this problem, I know that it should be close to 18. Then I'm going to work this problem exactly. I am going to choose to change these mixed numbers into improper fractions so that I can just multiply two fractions. 5 and 7/10. Well, how many tenths is 5 wholes? I can say 10 times 5 is 50. 50 tenths is 5 as a whole number. And if I add that 50 to 7, I get 57 over 10 as my improper fraction. Now 3 1/3. How many thirds is 3 wholes? 3 times 3 is 9. So 9 thirds is 3 wholes, and then I add one more third and I get 10 thirds. Now I can multiply, but wait, before I multiply, I see that I could cancel a 10 over a 10. 10 over 10 is just 1. So now I can do this a lot easier. 57 times 1 is 57, and 1 times 3 is 3. Now, does this reduce? Is 57 divisible by 3? If you've learned any divisibility rules, you know that I can add the digits of the number and see if they are a multiple of 3. So 5 plus 7 is 12. So what I did is I added the digits. 5 plus 7 was 12. 12 is a multiple of 3. So I know that this will divide evenly. So I want to go ahead and do that. And if I don't know what it is, I can take it off to the side and divide. And it's 19. So 57 divided by 3, which is just what this fraction is, 57 over 3, is 19 as a whole number. Is that close to 18? Yes, it is. So we did this correctly. What about estimating what 396 times 312 is going to be? 96, I could round to the nearest 10, but this one already seems like that's really close to the nearest 100. So I'm just going to take that to 400. And then because 12 isn't all that close to 50, I'm not even going to try to round to 310. I'm just going to make it a straight 300. Sometimes you have to make a decision of, do you want to round to tens or do you want to round to hundreds? In this case, because mine are already close to the hundreds, I'm just going to round to the hundreds. 3 times 4 is 12. And then I have 4 zeros to tack on to put it in the correct place value. So this should be close to 120,000. All right, our last example to mentally estimate. We're going to estimate what 4,160 divided by 19 is going to be. Okay, I'm going to look at this 4,160. Do I want to round to tens, hundreds, or even up to 1,000? Well, if I were to do the thousands, the 1 is pretty low. So that's not going to change my answer a whole lot. So I'm going to go ahead and choose that one. So I'm going to round to 4,000. And then on this one, if I rounded to 1,000, the nearest 1,000, it would be at 0. And I'm not going to be wanting to divide by 0, so that's kind of silly. But 19 could round easily to 20. It's only one number away. So what is 4,000 divided by 20? We can think about putting it over as a fraction. I can then think about cutting this down by a factor of 10. So I'm going to cut both the top and the bottom by a factor of 10. So really, I'm just taking off a 0. So I have 400 over 2. Well, that's what is half of 400, or what is 400 divided by 2? That's 200. So my estimate is 200. Now, when I go to actually work this problem, if I don't get close to 200, I know that maybe I did some errors in my division. Estimating is a very good way to help you know whether you are close when you do your actual calculations.